Hello, and welcome to Casa Moss. My name is Martha, and it's great to speak to you today. In the next 25 minutes, join Max, Kian, Josh, Nathaniel, and me as we tell you about our new home. Casa Moss is an affordable, adaptable, accessory dwelling unit, or ADU, designed to serve the residents of Los Angeles and Southern California. In this presentation, we will show you how the modular architectural design is easily adaptable to fit a range of budgets and backyards. Casa Moss provides a resilient home that can withstand pollution, drought, earthquake, and other natural disasters. Our home is future-ready, with grid modernization capabilities including expanding to incorporate on-site solar storage and an electric vehicle charger. Casa Moss is sustainable. By using responsibly sourced materials and prefabricated construction, we reduce our carbon footprint, simplify installation, and reduce waste and cost. We efficiently insulate the home and install appliances to reduce our energy consumption, while also generating energy using solar to offset power usage. Casa Moss is an equitable source of income for local residents that resists neighborhood gentrification and puts control in the hands of residents rather than developers. And finally, by leveraging subsidies, Casa Moss is affordable, both for homeowners and residents, and it contributes to LA's affordable housing stock. In 2018, it was estimated that Los Angeles County needed to add over 500,000 new affordable housing units to meet demand. In January 2017, California passed legislation making it easier for homeowners to construct accessory dwelling units on their single-family zone properties as a way to address severe housing shortages. In their official findings, the City of LA identified 140,000 available lots that could accommodate ADUs in the South LA region alone. Our team recognized the opportunity to design a prototype for a standalone unit that could be easily and affordably replicated in backyards across LA. By leveraging ADU construction subsidies, our goal is to create a resilient future where local residents will be able to invest in their own land. Adaptability, affordability, and sustainability are key factors for the architectural design of Casa Moss. Since many ADUs are built on backyard sites with constrained access, we designed Casa Moss with modular, palletized components that can be easily transported and installed anywhere in the city. The base model, which includes one bedroom, is an affordable option that satisfies even the most rigid local housing restrictions. A second bedroom can be added, and the long rectangular base plan layout allows for multiple configurations. Casa Moss is a rectangle with the long sides oriented north to south. We take advantage of California's mild climate by placing windows on these long facades. As a result, our ADU can rely on passive cooling strategies for more than 73% of the year. By lifting the roof canopy, we create additional living space, while simultaneously shading the entire ADU to improve its thermal performance. Modular solar panels cover the roof and allow for installation as funds become available. On the exterior, our landscape design eliminates the need for supplemental water from irrigation. We use plants native to arid regions as a way to reduce our water usage, creating a beautiful backdrop to our ADU while also supporting our local ecology. On the interior, Casa Moss focuses on emphasizing the natural lighting provided by a series of large operable windows. The open floor plan maximizes occupiable living space by minimizing walls and hallways and creating areas that can serve multiple purposes. We select recycled and renewable finishes and avoid products that contain volatile organic compounds to create a sustainable and healthy interior environment. Home maintenance is easy with all plumbing contained in a single wall, which can be accessed through a series of wall panels. The plumbing wall is pre-assembled off-site for easy installation.
Construction on a residential site that is already occupied can be difficult, especially when dealing with limited access and noise-conscious neighbors. That's why Casa Moss takes a number of steps to minimize impact on the site. By using modular construction and prefabricating as many components as possible, we limit the time spent on the site and reduce disruptions to the residents and neighbors. Using a strip footing and stem wall foundation require less earthwork than traditional foundation methods, making large equipment unnecessary. This also reduces local soil disruption and air pollution, thereby reducing our environmental impact. Casa Moss practices sustainable construction through the use of structural insulated panels, or SIPs, which use recycled wood shavings. These panels reduce on-site construction time and create an efficient building envelope. Casa Mas is built on a stem wall foundation with a ventilated crawl space. Wood frame construction of the floor and the roof deck is insulated with loose fill cellulose to achieve an R40 insulation rating. We use R20 rated SIPs as the exterior walls of our enclosure. The water control layer is a waterproof membrane on the roof, a coping on the parapet, and a back ventilated rain screen facade made of vertical wood composite battens. The structure is moisture isolated from a drained foundation wall. Our plumbing system is contained within a single wall between the kitchen and the bathroom. This makes construction and maintenance much simpler. Parts of our system can be easily replaced or fixed by access through the kitchen or bathroom wall. With the localized design, supply to appliance distances are short, so pumping energy and water heat are more easily conserved. Supply lines will be made of galvanized iron, while wastewater lines will be made of PVC due to lower fluid pressure. The slightly downward sloping wastewater lines allow the wastewater and sewage to easily flow into the wastewater main line. To reduce the possibility of backups or clogs, the vent stack supplies airflow to assist with outflow of wastewater. In order to save water, a gray water system will be used to supply toilet water. Gray water from the shower and washing machine is diverted to a gray water tank in the maintenance room, and a pump supplies water from the tank back to the toilet. Casa Mas is designed to maximize passive energy performance. The long sides of the structure are oriented north to south, maximizing daylighting on the interior without exposing large facades of the building to harsh western sunlight. Operable windows allow cross-ventilation and passive cooling of the space. The solar canopy is positioned to shade the south-facing windows in the summer when the sun is high, while allowing sunlight into the space in cooler winter months to provide solar heat gain. Through design strategies such as shading, natural ventilation, and solar heat gain, we can passively maintain a comfortable living environment for almost 75% of the year. As a result of favorable climate change and small size, the hot water heating and interior equipment make up the bulk of yearly energy consumption. Heating consumption ramps up in the winter, with a peak of electrical consumption seen in the evening throughout the year. With a small footprint and a full fit of our space, our house alone achieves an energy use intensity, or EUI, of 38, which is well below the typical house in the US. With renewable energy generation offsetting the electricity consumption, our site EUI drops to -1 with 16 panels and -10 with 48 panels. Our energy generating system is both cost-effective and can be modified to fit user needs. An array of 16 solar panels yields up to 10,000 kilowatt hours per year, making Casa Mas net zero. Thanks to a canopy structure, the initial affordable configuration can easily mount up to 48 panels. Currently, the solar cells connected to optimizers feed the local power grid during daylight hours, while the grid powers the house at night. The electrical system's flexibility works perfectly with Casa Mas's modular design. Should the homeowner choose to add solar panels, they can augment this by installing a battery, which facilitates saving money and limits strain on the grid by peak shaving. With the battery, energy generated during the day can be used at times of peak power consumption. This prevents the user from relying on the grid when it's most expensive. With 48 solar panels, Casa Mas would produce 3 times the electricity that it consumes, making it a significant net producer in the community. It could work with other such installations throughout the community to function as a virtual power plant. We can imagine a future where utility companies focus on energy storage and load balancing, and energy generation is distributed throughout the city.
Due to its small size and optimal window placement on both sides, Casamas can take advantage of prevailing winds blowing from the south to increase the range of thermal comfort in the summer by up to 5 degrees. When poor air conditions outside do not allow for this, fans replace the natural air movement effectively. With a building envelope air tightness of 0.35 air changes per hour, our building depends on mechanical ventilation to maintain indoor air quality. An ERV supplies fresh air while conserving the energy of exhausted air. Casamas provides ample interior day lighting. Analysis shows that passive lighting strategies are sufficient to illuminate the interior for over 75% of daylight hours. When interior electric lighting is required, Casamas primarily uses dimming LEDs because although they are more expensive than standard LEDs, they are much more energy efficient. One of the recurring themes in the design of Casamas is its ability to adapt to diverse occupant needs. In this spirit, we carefully designed the operational aspects of the ADU to work for all age groups, socioeconomic statuses, and levels of tech savviness. As is, the house comes with appliances and embedded IT infrastructure. The simplified design makes for a great user experience, in addition to environmental and financial efficiency. Our appliances maximize efficiency and lifespan to reach financial and environmental targets. Everything is electrically powered, allowing us to use renewable resources and also decreasing costs related to gas piping. Reliable internet access is critical in the modern day. Casamas has a built-in local area network, or LAN, ready to be connected to DSL or cable. The system is robust enough to support the most ardent of computer internet users, including remote workers. In addition to basic network connectivity, Casamas leverages the inbuilt LAN with Internet of Things for added security and environmental control. Many computers called Intel Edison boards are installed around the house in CAD enclosures. An inbuilt mini server handles all of the devices and relays communications to the LAN and cloud. By using one standardized hardware and software approach, instead of using various proprietary industry solutions, we have been able to simplify controls through one centralized, integrated user interface. The status and configuration of every IoT device in the home is accessible through the Casamas mobile and web applications. The user interface is a simple set of active devices, their current status, IP address, and configuration information. Also, everything works out of the box. There is no initial setup of the sensors. They're all pre-configured to connect to the LAN and cloud. We understand the financial constraints of many users, so we included the bare minimum to be inbuilt into the unit. These include a door lock, electrical switches for light control with dimming capabilities for dimmable lights, flow rate meters that provide water usage statistics for the whole unit, as well as for the shower specifically, an electricity meter for unit power usage, a smart thermostat for temperature control that connects to Flex Alert, which automatically changes temperature settings in the home to reduce grid strain and prevent brownouts. And finally, a floater in the gray water collection system that reports fill level. All of these statistics feed into the user interface, and we form recommendations to adjust settings for optimal utility usage and comfort. For those with more technical experience who want to access to lower level hardware configuration settings, we make it easy to do so. The Edison board Linux systems can be accessed via standard network protocols like SSH and can be completely reconfigured to the user's liking. All software deployed is open source and published on GitHub for full transparency. In addition to modifying existing devices, the network can be easily expanded by users. Devices like irrigation control or smart speakers can be added to the system at will. Through our appliances and IoT, the day-to-day operation of Casamas becomes both data-driven and easy to use for all.
California must contend with a number of disasters, both natural and man-made. These include earthquakes, droughts, fires, floods, and power outages. With fault lines running throughout Southern California, planning for earthquakes in our design was essential. In an earthquake, our foundation footing helps to resist sliding and uplift by providing a wider base and added friction with the ground. The inverted T-shape of the foundation also prevents overturning because there is additional soil weighing down the footing to keep it in place. Strong connections help resist the horizontal and vertical loads experienced in an earthquake and minimize independent movement at the foundation-to-house interface. In California, droughts are becoming increasingly common, and Casa Mas takes several steps to maximize efficiency in water usage. Through the use of water-saving plumbing fixtures and gray water reuse on the interior and xeriscaping on the exterior, we significantly reduce our total water needs. To protect against flooding, Casa Mas has a raised foundation and sloped landscape, providing adequate drainage and insulating the structure from the risk of water damage. Though the Casa Mas prototype is not built in an area with an increased fire risk, we designed it to be adaptable to backyards across Southern California. As such, we selected cladding and canopy construction materials composed of fire-resistant wood and plastic composites, which not only protect against fire damage, but also use recycled materials. Our solar panels allow Casa Mas to function in daytime, even during a blackout. Though the base of the model of Casa Mas does not include a battery, it can be easily upgraded to include one to expand our blackout functionality to all hours of the day. To future-proof our home, we designed an adaptable modular energy system that can be upgraded with increased generation and storage capacity when needed. Although 16 solar panels are sufficient to reliably reach net zero energy goals, the canopy system can be expanded to host up to 48 panels, doubling energy production. Additionally, demand response technology allows the home to serve as a local energy generation hub in a larger virtual power plant.
Located in South LA, Casa Mas is a prototype that can be used to pioneer the adoption of ADUs in one of the most underserved areas of the city, where a large percentage of residents live below the poverty line. Close to many hubs and beautiful recreation areas, South LA has recently become a target of development as downtown commuters search for housing amid the severe shortage. Casa Mas enables homeowners to capitalize on the growing real estate market rather than being displaced by outside developers. Through a strong commitment to adaptability and affordability, our design allows homeowners to obtain a reliable source of income and renters to find an affordable home. Where does Casa Mas stand on the micro scale? Casa Mas is close to major public transportation and cultural hubs, making it incredibly easy to navigate the city for very little cost. Those who don't have a personal vehicle will not be subjected to use costly share rides, which are ever so common in Los Angeles. Additionally, Casa Mas is uniquely located next to major bike routes for leisure, exercise, or utility. These geographic components alone make Casa Mas a very attractive place to live. What challenges does the community face? More than 53% of South Los Angeles residents earn an income of under $50,000 a year. This is far below the state average. With more than 60% of the population renting living spaces, this presents a unique challenge to the region in terms of affordable and available housing. The average rent price in South LA is $2,500 per month, which is far more than most residents can afford. Last year alone, rent prices increased 4%. This vicious trend has created intense displacement pressures on a helpless community at the clutches of gentrification. How exactly will Casa Mas help the occupant and the community? The green technology and design features of Casa Mas will save occupants over $100, putting money back into the pockets of low-income residents, making Casa Mas affordable for the occupant. Second, Casa Mas and other ADUs will increase population density in the area and in fact stabilize rent prices due to the influx of available living spaces. As supply of apartments increases in the area, rent price will begin to stabilize, helping to reverse the trend of displacement. This multifaceted approach will help create more sustainable living solutions for the community as a whole, as well as the occupant, greatly reducing the current trends of housing precarity. How exactly will Casa Mas help the homeowner? Casa Mas is incredibly cost-effective in terms of construction cost per square foot. Casa Mas comes in on the very low end of the spectrum, costing a projected $160 per square foot compared to the typical range of $100 to $400. This provides an incredibly attractive offer to the homeowner looking to build an ADU in their backyard. Additionally, the passive energy income generated from Casa Mas can be used to pay off any loans needed for construction and some. The monthly payment in a typical loan of this type would be just over $700 a month. With a rent income of around $1,800, the homeowner would still be pocketing over $1,000 a month while paying off the principal amount. It is also projected that ADUs increase total property value by 10 to 30% after calculating the added value of the ADU itself. With the uncertain times of economic growth ahead, rent-based passive income is something all individuals should be seeking. On top of this, there's also a government-subsidized ADU accelerator program. This program pays $10,000 to any homeowner who's willing to rent their ADU for 3 years to low-income and at-risk renters. This adds even greater incentive to the homeowner for the construction of Casa Mas. How could we make this affordability achievable? There are a few main design features we focused on to limit production costs. First, we decided to construct the exterior walls from SIP panels. These panels are prefabricated and limit overall production costs and are sustainable. Second, we decided to use a composite batten for the exterior wall finish instead of a classic wood batten or metal batten. Not only is this composite batten more cost effective, but is also resilient to fire damage. Lastly, we chose to use a similar composite material in the construction of the canopy instead of expensive metal framing. Overall, these design features saved us around $14,000. How reliably can we take our construction estimates? We have confidence in the accuracy of our construction costs for a few main reasons. Firstly, Casa Mas is a modular design and is constructed from prefabricated components. Modular designs allow for greater certainty in projections as everything is made perfectly to specifications before the house is actually constructed. Additionally, a key feature in our construction cost confidence is the one main plumbing wall in the house. This simplified feature greatly reduces margin of error that can lead to greater expense. Lastly, Casa Mas is small in size, limiting potential errors that could generate greater cost. Although Casa Mas is small, it offers so much more to the community.
As we've shown, Casa Mas is innovative in many ways. Through efficient and thoughtful engineering, Casa Mas has taken full advantage of available technologies to maximize comfort while minimizing complexity. Our kit of parts approach to construction allows us to easily adapt to a variety of site conditions while keeping costs low and reducing waste. The plumbing wall simplifies construction and maintenance and reduces cost, while also minimizing heat loss and pump work. Casa Mas demonstrates sustainable energy management. With a set of scalable solar installations and smart energy management technologies covering its operational needs, Casa Mas will start out as a net zero energy home and can grow to support an electric vehicle or become part of a virtual power plant. Our ADU is responsive to sudden shifts in local conditions and can be adaptable to changes in user needs. Fitted with fire-resistant materials, solar-powered fuel cells, and drought-resistant plants, Casa Mas is highly resilient to sudden shifts in local conditions. The canopy structure provides patio space, shades the home, and can be converted to a second story. Our modular construction system also allows new rooms to be added freely on the ground, making the unit both vertically and horizontally scalable to accommodate homeowner needs. And the strip footing foundation minimizes site disruption to ensure that neighbors will not be disturbed during construction. Casa Mas is an innovative solution to housing shortages in Los Angeles. Our adaptive, high-efficiency ADU provides financial and societal benefits for both owners and renters. With Casa Mas, we imagine a more sustainable, equitable, and resilient future, and we hope to see these innovations and attitudes adopted across the world. Thanks for joining us, and welcome home.